The General Aviation Joint Steering Committee topic of the month for May is safety wire. Failure to properly secure aircraft components has led to system and component failures. Some of those failures have compromised power plant and control system operation, resulting in crashes. Asking the question, why isn't this bolt safety wired, is a rational question. If you're used to seeing a piece of hardware with a locking device and you notice the locking device is missing, then ask the question. It could very well save your life. On the 27th of May of 2018 in Houston, Texas, a Cirrus SR-20 airplane crashed shortly after takeoff. The pilot reported that he could not maintain roll control of the airplane. The airplane began to roll to the left. The pilot was able to counteract with right aileron input initially, but the airplane continued to roll to the left. The pilot continued to use right aileron and trim, lowered the nose, and executed a straight-in forced landing just beyond the departure end of the runway. The pilot survived with minor injuries. Examination of the airplane after the accident revealed that the left aileron actuation arm and attach bolt were missing, with no associated impact damage. Further investigation indicated that the safety wire was missing from the actuation bolt, indicated by the red arrow. As the bolt is readily visible during a walk-around inspection, we recommend that all owners and operators visually verify the presence of the required safety wire before further flight. If safety wire is not present, have a qualified maintenance provider correct the situation before further flight. This airplane took a test flight with the brake caliper and hub nut finger tight. See the gap between the cylinder and the brake pad backing plate? If there's a hole in it, it should have a safety wire in it, and if it doesn't, it's time to ask the question, why isn't this bolt safety wired? There could be good reason, or it could be that maintenance is not finished. I know it may sound a little condescending to start here, but most mechanics say this inside their heads several times a day. Never out loud. Do you see the key reason the person who safety wired the oil filter should have asked himself this very question? Here are 2 bolts prevented from loosening by safety wire. To evaluate the effectiveness of the safety wire, first say the words, righty-tighty, lefty-loosey. Then, ensure that the safety wire is applied so that it is in tension in the direction that would cause the bolt to tighty. Be sure to ask yourself the same question on the other bolt too. The AC 43.13-1B calls out for 6 to 8 twists per inch. It's probably not required for you to pull out your ruler and calculator. Just notice that there's a difference between a nice tight job and a sloppy one. Nothing says, I don't care, like a bad safety wire job. If you see this, it might be worth checking to see what else could be screwed up. This airplane was pulled out of the San Francisco Bay. The traffic reporter that owned the plane had a radio transmitter installed with safety wire, which is a whole new world of wrong safety wiring. This isn't safety wire, but it is another issue that might cause you to ask a question. See how the locking fiber is not contacting the bolt? The AC 4313 will say, after the nut has been tightened, make sure the rounded or chamfered end of the bolt, stud, or screw extends at least the full round or chamfer through the nut. Flat end bolts, studs, or screws should extend at least 1/32 inch through the nut. Here's another issue that should bring a question to mind. See how the red arrow points at the fiber lock nut? Look closely at the nut at the pointy end of the arrow. It is not a lock nut. Post-accident examination of this airplane revealed that an elevator flight control cable rod end had separated from its turnbuckle connection, which resulted in the pilot losing control of the airplane. No safety wire was found at the connection of the turnbuckle in the separated cable rod end, even though it should have been safety wired according to the proper maintenance procedure. It is likely that the unsecured connection gradually loosened over time until it finally disconnected during the accident flight. Turnbuckles should either have safety clips as depicted in the left picture or safety wire as shown in the right picture. Here is the picture from the beginning of the presentation. It depicts an aileron cable separation. This airplane had been flying without a noticeable change in handling. It is a save for safety wire, but a reminder to inspect control cables. The American Bonanza Society is aware of 6 recent cases of failure of the swaged end of the flight control cables at the turnbuckles in Beech piston airplanes. In all these cases, the failures resulted from corrosion of the swaged end of the cables and turnbuckles located beneath the heater ducts, in the case for the aileron cable, or beneath the overhead fresh air inlet duct in the aft fuselage for the rudder and elevator cables. This is a castle nut. Castle nuts require a cotter pin in order to lock them in place. In this case, a Piper tripacer experienced an off-airport landing and substantial damage due to the throttle cable coming loose. The castle nut that holds the throttle arm to the carb was loose and did not have a cotter pin installed. According to the pilot, the airplane had been returned to service after being restored by an airframe and power plant mechanic with inspection authorization. The pilot performed several takeoff and landings prior to the accident flight, and he noted that the airplane seemed to operate normally. The pilot departed to another airport where he completed a simulated instrument approach to about 50 feet above the runway. He then commenced to go around over the departure end of the runway with the airplane 300 feet above the ground. The engine experienced a partial loss of power, and the pilot maneuvered the airplane to a hayfield where he performed a forced landing. During the landing rollout, the horizontal stabilizer struck a hay bale, resulting in substantial damage to the empennage. A post-accident examination of the wreckage revealed that a cotter pin was not installed on the throttle arm retaining nut. The throttle arm retaining nut was finger-tight, and the throttle arm was loose, which resulted in excessive play in the throttle linkage. August 27, 2018 in Yuma, Arizona. About 37 minutes into this flight, the pilot noticed that the engine manifold pressure was dropping, along with the airplane's airspeed, which is consistent with a partial loss of engine power. The engine then experienced a total loss of power while it was maneuvering for an emergency landing to a nearby airport. The airplane subsequently landed short of the runway and sustained substantial damage to the aft fuselage. Post-accident examination of the engine revealed that the throttle linkage had detached from the throttle arm of the fuel injection servo. The rod end bearing for the linkage and the throttle arm were intact and undamaged, but the connecting bolts and its associated washers, castellated nuts, and cotter pins were missing. It is likely that the bolt securing the linkage had not been sufficiently tightened and secured with a cotter pin during the installation. May 7, 2016 in Surprise, Arizona. A flight instructor was asked to complete a maintenance test flight of the airplane following the installation of a repaired carburetor. He elected to use the flight to provide instruction to another pilot who had requested a checkout in the airplane. The check pilot reported that the flight was initially normal, but then the engine stopped responding to throttle control. According to the check pilot, the engine remained at idle power as the airplane descended and impacted trees to a residential area. Examination of the wreckage revealed that the carburetor throttle cable was detached from the throttle body linkage. The bolt and castellated nut used to secure the throttle cable to the linkage were found laying separately in the engine cowling. There is no evidence that a cotter pin had been used to secure the nut on the bolt, as required. It is likely that the loss of engine power resulted from the failure of the mechanic who installed the carburetor to install the cotter pin when he attached the throttle cable to the carburetor. During the maintenance test flight, the castellated nut backed off the bolt, which resulted in a loss of throttle control. There are many other parts that require safety wire or other means of locking. The FAA publishes an advisory circular that outlines the various locking methods. For more information on aircraft fastener safety, search AC 43.13-1B. AC 43.13 is free online, and in Section 7, you'll find the definitive reference for aircraft fastener safety.
There's nothing like the feeling you get when you know you're playing your A game, and in order to do that, you need a good coach. So fly regularly with a CFI who will challenge you to review what you know, explore new horizons, and they challenge you to always do your best. Of course, you'll have to dedicate time and money to your proficiency program, but it's well worth it for the peace of mind that comes with confidence. And be sure to document your achievement in the Wings Proficiency Program. It's a great way to stay on top of your game and keep your flight review current. If you have any questions regarding this presentation, you can come to our Facebook page, Main Flying, and post your questions, or on the YouTube channel below, or you can always seek out your local CFI or contact your local FSDO for an FAA safety team representative near you. Thanks for watching this video, and remember, you are a vital member of our general aviation safety community.